Okay, this example is about mammograms. It says many women choose to have an annual mammogram to screen for breast cancer after age 40. A mammogram isn't foolproof. Sometimes the test suggests that a woman has breast cancer when she really doesn't. That's called a false positive. Other times the test says that a woman doesn't have breast cancer when she actually does, and that's a false negative. Suppose we know the following information about breast cancer and mammograms in a particular region. 1% of the women aged 40 or over in this region have breast cancer. For women who have breast cancer, the probability of a negative mammogram is 0.03. For women who don't have breast cancer, the probability of a positive mammogram is 0.06. So these two results are incorrect results. These are your false positives and your false negatives. Okay. A randomly selected woman aged 40 or over from this region tests positive for breast cancer in a mammogram. Find the probability that she actually has breast cancer. So when you read this, it's not going to say, hey, you need to go do a treat. You need to see this as two events. The first event is either you have breast cancer or the woman doesn't have breast cancer. The second event is getting the test results. Okay? So my first stop is women, and this is over 40, and this is who has mammograms. Okay, so either the woman has breast cancer or they don't. That's the first event. Okay, so let's go back and read, and let's see if we can find the probability of women who have breast cancer. Right here. 1% of the women aged 40 or over in this region have breast cancer. That's not 1% of the positive test results. That's why this event is first. It's 1% of everyone who gets a mammogram has breast cancer. So we're going to go 0.01, and this is going to be 0.99. Okay. Now, these women come in and have a mammogram. When they have their mammogram, they either get a positive test result or a negative test result. And the same thing for if they don't have breast cancer. Okay, so let's go back and read. It says for women who have breast cancer, okay, that's this top branch. The probability of a negative mammogram is 0.03, which means this probability is a 0.97. So 97% of the women who have breast cancer get a positive test result, but 3% of them get a negative test result, meaning they have breast cancer and they don't know it. The test doesn't say that they have it. Okay, for women who don't have breast cancer, so that's the bottom blue branch, the probability of a positive mammogram is 0.06. So this is, they don't have breast cancer, yet they get a positive test result. That's called a false positive, which means 94% of the time the test gets it right. Okay, so there's my tree. It says a randomly selected woman age 40 or over from this region tests positive. So I know that she tests positive. So this has happened or this has happened. Find the probability that she actually has breast cancer. Okay, so you have to decide, is this an and or is this a given? A randomly selected woman age 40 or over from this region tests positive for breast cancer. So I know that she has tested positive for breast cancer. I want the probability that of those people, how many of them actually have breast cancer. So this is a given. I want to know the probability that she actually has breast cancer given that she tests positive. I know this has happened. I want to know of this, how many of them actually have breast cancer. Okay, so you have to think about your given formula. So this is the probability that she has breast cancer and test positive over the probability that you test positive. And that's just a formula. You need to memorize it. It's the probability of A and B over the probability of B. Okay? Now, for your and, you also have a formula for and the tree kind of does it in the tree, which is wonderful, which is why I love trees. But an and formula, the probability of A and B is the probability of A times the probability of B given A. Well, the probability of A is that we have breast cancer. Well, that is 0.01. The probability of B given A is in this number right here. Like that 97% is not all tested positive. That's tested positive given that I know that I have breast cancer. That's why it comes off of that branch. So this 0.97, this has already got the given in it, which is why when I do this and, I can just do 0.01 times 0.97. I don't have to do the official whole and formula because the and formula has a given in it, and this tree already takes that into account, that 0.97. Okay. Now, testing positive is a little trickier because I can test positive two different ways. This woman can have breast cancer and test positive, or she cannot have breast cancer and test positive. So two different ways that can happen. So I'm going to do have and positive, or don't have. And test positive. So let's see, have and test positive. Have and test positive plus, because that's my or, don't have and still test positive. Okay, now if you're going to type this in one swoop, you need to be super, super careful because if you're going to do 0.01 times 0.97 and then divide it by, then you have to put all of this in parentheses because it has a plus sign in it. You can do the top and then hit enter and then do the bottom and hit enter and then divide them if you want to. Whatever you're comfortable with doing. Guys, I need you to practice typing this in. The answer is 0.14. I don't know why I only went 2 decimal places. But I need you to pause the video and type that in and make sure that you're getting 14%. The worst thing would do to get all your stats right, but then have a calculator error and miss your answer. So pause the video, type that in, make sure you're good. Okay, last one. Computer company makes desktop and laptop computers in factories in 3 states, California, Texas, and New York. California factory produces 40% of the company's computers. Texas makes 25%, and New York makes the other 35%. Of the computers made in California, 75% of laptops. Texas and New York are 70 and 50% respectively laptops. All computers are first shipped to a distribution center in Missouri before sent out to stores. Suppose we select a computer at random from the distribution center. Okay, so number 1 says construct a tree. Number 2 says find the probability that the computer is a laptop. And number 3 says given that the laptop is selected, what's the probability that it was made in California? Here's my challenge for you. Pause the video and do number 1. Then hit play and watch me make the tree and check your tree. Then hit pause. Then on your own, do number 2. Then play the video and check your number 2. Then pause the video and do number 3. And then check your number 3. It's really easy to sit here and just watch me do this. But since this is the last example, let's see if you can do this on your own and then use my example to check your work. So pause the video and construct your tree. And I know I'm going kind of fast, but I expect you to have already done this and you're just checking it. Okay. There's your tree. Okay, now hit pause and do number 2, but do formula, numbers, answer, make it test appropriate. So 65% probability that the computer is a laptop. Okay, now pause, go do number 3, and then hit play when you're done. So 46.2%. Okay, so hopefully this gives you a little bit more practice and fine-tuning some things about what's expected in terms of formulas and the intersections and the unions and when to plug your numbers in and the givens and the ands and all that stuff. So I hope this helped, and more practice on your homework should do the same.